Okay, we gotta talk about him. He who must not be named. Not that. That was a terrible circle. Let me try again. That'll do. That'll be fine. He who must not be named. Don't talk about him. Don't mention him. His name is Tangent. Ooh, scary. Okay, listen. Um, Pretend this is a unit circle. Okay, we have an angle of theta. Okay, we have an angle of theta. And we've been over this, that this dot right here, the point at which the intersects, the x point at which it intersects is cosine of theta. And the y point at which it intersects is equal to sine of theta. You know, all that good stuff. It's equal to x of theta. And we know that tangent is equal, tangent of theta is equal to sine of theta over cosine of theta. But sine and cosine of theta are y over x. Does it seem kind of familiar? Well, if you really think about it, y, x, right here, is the same thing as equal to y minus 0. From this point to this, from this 0 point, which we know this angle passes through, to this y point right here is y minus 0. So the change in y from this point to the y, is equal to y minus 0. To y minus 0, which is just equal to the y. And the same thing can be said for the x. From this 0 point to this x right here is going to be x minus that 0. So this x, so the change in x is going to be equal to x minus 0, is just equal to the same x. Well, if this is equal to the change in x, the y is equal to the change in y, the x is equal to the change in x, then that means the tangent is equal to the change in y over the change in x. What? So the tangent is equal to the slope, because that's the formula for the slope. So the tangent of this angle is equal of theta. The tangent of theta is equal to the slope of this line right here, of this angle. That's it. That's all I wanted to say. Okay, stay in school.